or 3-4, solving logarithmic equations, and a couple different things, ways you can solve logarithmic equations. Either you rewrite the thing in exponential form, and that helps sometimes, or you can set the two sides of the equation equal, or you try to get the equations such that you're taking a log of a quantity that has to be the same on both sides. Okay, so for instance, if I have this one, 2 log of x is equal to 5, just like that, and they say solve. Can you do that? Say yes. Yes. Okay. So what I would do with this one is rewrite it in exponential form. What's down here? Oh, first of all, what should I do to get rid of that 2? Divide it away. Okay. So the first thing I would do is divide away that 2. So you want to get log of x equals 5/2. And then there's a base 10 down here. It's just plain old common log. There's base 10. So you could write this as in exponential form as 10 to the 5/2 equals x, right? And then so you can just, that's not something that comes out really nice and neat, I don't think. So you would just plug that into your calculator at that point, and you would get 316.228. Questions? Easy? And I would take things to 3 or 4 decimal places. I don't remember. Just get in the habit. And the other thing that's nice to get in the habit of is, hey, look, they're doing logarithm problems up there, just like we are. Except they're doing it with calculus and sequences and series. But notice that they're using the laws of logarithm. Okay, so if the other thing to be careful of is, like I said before, you want to try to solve your equation algebraically for x and then plug it into your calculator whenever that's possible. You don't want to like plug in something and then round it off and then continue with your equation. You want to wait till the very end because you're going to lose accuracy if you do that. And I believe on the AP test, when you take Mrs. Heim, I'll tell you this next year if you take BC or AP, whoever teaches that. But they like things taken to 4 digits, okay? So get in the habit of the 3 or 4 digits, unless it says otherwise to the nearest 10. So, and they do take off points if you don't round it off. Either truncate it or round it to the correct place, okay? So what if I saw something like this, natural log of the square root of x plus 2 equals natural log of x. This is really easy. You can tell me what I would do with that. ln x squared. Yeah, you could just take off the ln, right? Because the ln of this is equal to the ln of that. And I would have x plus 2 equals x. Is that right? The square root of x plus 2. Square root of x plus 2 equals x. And then I have to go through some algebra here. I have to square both sides to get rid of the square root. So I get x plus 2 equals x squared. And then I want to bring everything onto one side. I'm going to go x squared. I'm going to bring these onto that side because I like to lead with a positive coefficient. X minus 2 equals 0. And I'm going to factor that to x minus 2 and x plus 1 equals 0. And then I'm going to draw a little squiggly line. And then I'm going to go x equals 2 or x equals negative 1. And then one of those answers you throw away. Which one? Negative 1. Why?
Because you can't put it.
Yeah, because you could only take the natural log or the log of a number that the domain of natural log has to be greater than 0. Okay, so you can't take the log of a negative number. So you throw this one away, and that's your answer. Okay? Yeah? Good? All right. So that's how you do that one. What if you see something like this? Next page, new page. What if I had something like log of x minus log of... These are just kind of fun little log problems, I guess. Equals 1. Who thinks they could tell me what to do with that one? Joey?
Divide log base x by log
Yep.
x minus 3.
So with this one, the trick here is you can't like factor out log. Don't do this. This would be a bad no-no. You wouldn't do this. X minus 3. You can't do that. Okay, you can't just factor out the log like that. But what you can do is what Joey said is you can write this as a division of logs, right? Using those properties that we have. And then what would I do? What's next?
Multiply x minus
Sam?
It said 10 equal to x over x minus 3.
Right, because there's a 10 down here, right? So 10 to the 1, right? 10 to the 1 equals x over x minus 3. So I just rewrote an exponential form. Now I cross multiply, and I get 10 times x minus 3 equals x, what else? 10x minus 30 equals x, 9x equals 30, x equals 30 over 9. So x equals 10/3, right? Which is that reduced. And then always make sure that your answer is in the domain of the original function. So I think, does that work in here? So it's 10/3 is, it works. Yeah, it's bigger than 3, right? So you can take the log of that, and you can take the log of that. So that works. So you're okay. So that's your answer. But always take your answer and check it in the original equation to make sure that it's in the domain of the original function. All right, and then we're almost done. Oh my goodness. All right, so the last thing, what if I see something that looks like natural log of x minus 3 equals negative x squared plus 14. And they say solve for x. Solve for x. What might you try? What's down here? There's an e, so you might try going e to the this equals this. But that's not going to help you because you're going to have an x squared in the exponent, and then you're going to have an x down here. So when you see something like this, really the only way to solve it is with a graphing calculator. And so what you're going to do is graph y equals natural log of x minus 3, and y equals negative x squared plus 14, and see where they crop. And that's a really good technique because I know with calculus they do it a lot with like really complicated integrals and stuff. Your calculators could do integrals, and you have to set the integral equal to something, see where it's equal to some value. So it's a good idea to get used to if you have an equation that's impossible to solve with algebraically, then you use your graphing calculator. So just to show you how you would do that, to review, because we have plenty of time today. Always close it. So I would just take, and it's good practice for setting up your windows and stuff like that. Oh, I almost had it. Y equals natural log of x minus 3, which is going to be a log function shifted which way? 3 units to the right. And what's this thing going to look like? An upside down parabola with a vertex at 0, 14, right? And so the other thing, it's really a good idea to get in the habit when you're solving these things to
Negative x squared.
Oops, negative x squared. To have a sense of what they look like. Okay, so second, insert, negative. Whoops, let's just clear that whole mess. Okay, negative x squared plus 14. And then make sure your window makes sense. I probably want to go up to 14 so I could see the top. I don't know if I need to see the top, but let's at least go up to like 15 or something like that. And I have this window set up. If it's not enough, you could always, what the heck?
I think you did 115.
And you have a setup on.
Yeah, I got 115. That's my problem. Okay? And I have this stat plot on which I have to turn on. So this is good because sec deletes. I can delete that, right? And then, so second stat plot. If you get something that looks like that, you probably want to turn your plots off. Okay? And then if I hit graph, I should get a better picture of it. Well, not great, but so notice that this thing just kind of stops here because I have an asymptote, right, at x equals 3. But you don't have to worry about that. You just have to find this point. It looks like it's about, is it 0, 0? I don't think that's 0. Or let's see. So again, the way you do this, second calc, and you go to intersect, which is number 5, and then you say, it will say first curve, and it will just go to one of the curves. Which curve am I on? Oh, I'm on this curve. And you go to kind of close where you think first curve. Where am I? I'm on this curve. There I am. And you bring the little guy down wherever. It doesn't really matter, okay? And then second curve, it'll jump to that. And then you hit guess, and you go to kind of where you think the intersection. The reason they have that guess is because sometimes functions can cross in more than one place. So you want to get kind of close to it, okay? And then you hit enter, and then you would get that they cross. So it looks like it's at 0, but it's y is not 0, right? So x is 3.77, and y is 0.2544, but you don't really need the, I guess, they just asked you x. So the answer is x equals 3. What's that? What? My Mobius having problems. X equals 3.775, I guess, right? And that's how you do it. Okay? Easy enough? All right. So we're about done here. Homework. Let's see that homework. Where is it? But I don't want you to start on the homework yet because I want to give you this logarithm activity, okay, which is kind of easy. Go away. Index, pre-calc. Chapter 3. Where is it? This one, Wednesday, Thursday, 226 or 227. That's us. And let's see if I can copy that in purple. There you go. Where is it? So you can write that down. And with this logarithm activity, it's pretty easy, and I really want you to work with just one other person maximum, okay? You can work on your own if you want to. But I don't want you to work in a big group of 4 and copy from another group or anything like that. So are you guys going to work together?
Yeah.
Okay. You want to work by yourself?
Yeah.
Okay. gonna find someone to work
Yeah,
with?
that's one.
Okay. I'll give you guys can figure out someone to work. You found someone to work with? You find someone to work with?
I'll never go to
You don't have to. You could. Well, you guys could decide. Okay, I'll give you all one and you can decide who you want to work with, or you can work by yourself. Yes. Yes. So, just let me talk about this earthquake thing right here. Just read through it. I don't want to see anyone with their computers out because you can probably Google this and find it somewhere, which I did. I tried to take off all the things that would show you where I found it. Okay, but in any case, what you're going to do is talking about earthquakes and where they get the Richter scale from. And it's just the log of the intensity over 0.001, which I guess is the intensity of a minimal earthquake or something like that. And then they give you various earthquakes, and they tell you how much stronger is this earthquake, and then you can figure it out. Okay? But then for like part numbers 1, 2, and 3 in the first part, you really don't have to do too much work. But for the second part where it says answer the following Roman numeral 2, that one requires you to do a little bit of algebraic work there. So, and you can show your work on the back. That's fine. It's just it shouldn't take you more than like 10 or 15 minutes. So it's just kind of a good activity to see that there's real life applications to this stuff. And I'll give your homework back, and when you guys are done with this, I'll give your test back. An apple a day. Apple a day. 2 people max. I'm going to work on writing some more of your quizzes. You could ask me a couple questions.
I did kind of bad on my test, so is there any way to like, I don't know, but maybe retake or just do better on that one? Like something
I'll give it back.
Okay.
And I'll show you the work. What did I do with your papers that I was grading?
Oh my god.
I was raining your test.
He didn't give me the answer. Oh, which one is like
How do you break through value?
1057?
That's the
Okay. Get to work. Let's finish this up in 15 minutes. Okay. I kind of want it to be like a in-class thing that you get done with in class. All right. In 15 minutes.
So I think the second one.
Bad apple.
The greater one. Okay. Oh,
Oh, in the same year as the breakthrough value of the earthquake. So it's the breakthrough value.
Last one was like, did you go?
Easy.
Log base 10.